Hello and welcome to Non 11. This brief tutorial describes how to configure and build the PIVX cryptocurrency project on a MacBook. I'm going to first go through briefly what PIVX is and why I think it's an excellent project for developers and aspiring developers that would like to start working in the crypto space. And then we'll get into some nuts and bolts of how to pull the source from GitHub, how to configure and build on a MacOS. I'll be giving examples with a MacBook with an M1 Pro processor. And then I'll show how to configure Visual Studio Code, which is Microsoft's free version of Visual Studio that works for the Mac, with the CMake files that are available through PIVX. So a little bit about the PIVX project. PIVX is an open source cryptocurrency project that is focused on privacy and proof of stake. In fact, it's really a pioneer in proof of stake privacy coins. You've likely heard of other privacy coins. It's actually getting more and more attention these days as people realize the importance of privacy in cryptocurrency. Coins like Monero and Zcash, a lot of those are still proof of work. Some of them are moving to proof of stake. PIVX has actually been proof of stake for some time, which has some really nice advantages. The project's been around for a long time. It actually got started in 2016, and it was, in fact, a top 10 cryptocurrency. It's always been known for technical innovation and a very supportive community. So you can go to pivx.org and you can learn a little bit more about the project. That's one of the reasons I think it's a really nice project if you're a developer to get involved with. It has that pedigree, that history, and it also has a great supportive community. And it's actually a mature and robust code base, but it is still evolving, which is nice. The cryptocurrency lays claim to a lot of firsts. It was the first proof of stake project with masternodes. It was the first proof of stake blockchain project that has blockchain-based governance, and that's really where the DAO comes in. One of the other nice things about PIVX is that it is fully decentralized. There is no underlying corporation. It is fully governed by a decentralized autonomous organization, which means that you can make proposals, even development proposals, to the community, and the community will vote on which ones to fund out of the treasury. So if you're a developer and you see a need for a feature, you can go ahead and propose that. It's all automated through the tools that PIVX provides. And then if it's accepted by the community, they will fund that proposal. So before we go and pull the source code from GitHub, we're going to want to download a couple of tools. The first thing that you're going to want to do, a lot of this is going to be done through the command line. So you're going to need to open up a terminal on your Mac. And Macs kind of have Linux running under the hood. And you can open terminal just by typing terminal into the spotlight, and it will launch one for you. I already got one open, so I'm not going to do that. So what you're going to want to do, if you don't already have it, is download a package manager called Homebrew. And this is a very nice package manager for Mac, and it will make it easy to install the various utilities that are going to be required to build the PIVX code base. So make sure you're at the right website. Go to this URL, which is brew.sh, and all you need to do is copy this command and paste it into your terminal window. So this is actually going to download a script and run it, so you want to be very careful that you're at the right website and not some spoof site, because this is, something that you need to be careful about. You can copy this line by just clicking here, and now it will be in your paste buffer, and you can now just paste it right into the terminal by typing Command V. That's the line, and I already have this installed, and you're going to see many slightly different feedback on my terminal than what you get because everything's already been installed on my computer. So I just want to kind of go through this. So you can see here, first thing it asks for is sudo access. So that means it needs administrator rights to do this, and so you need to put in the administrator password, which I'll do, and poof, there it goes. And it says it will install that. Hit return, and it's downloading and installing. Again, it's going to be a little bit different for me than it is for you. What you need to do after installing is make sure that Homebrew is in fact in your path. And let's just see here. So if you type which brew, you can see that it already is for me. If that's not the case, then you're going to need to add that to your path. And let me just find. And the two commands that you will need to add to your path are these. I'm just going to show them here. So the first one is echo eval this long line into your Z profile, and the second one is actually evaluating that. Now, I'm not taking a lot of time for this, because when you first install Homebrew, it will tell you that you need to type these two lines into the terminal in order for it to be in your path. So what will happen the first time before you enter these two commands, if you type which brew, it will not say a location, it'll just say can't find it. But again, the install script is pretty good, and it will tell you that you need to do that right at the end of the install. It didn't do it for me because I already had it in my path. Okay, so now we have Homebrew installed, and we can use Homebrew to install Git. So in order to do that, I'm going to bring up the now we're getting started with the actual PIVX commands. And they kind of tell you how to do that. But even before that, let me just go ahead and write. It's very simple. Just type brew install git. And again, I have this installed, so it's going to look differently for you. Okay, already installed and up to date. So that's basically saying that it's there. Now for you, it's going to go get the latest bundles, install Git on your system. And you'll know that Git is installed because if you type which Git, it will find it, or Git help. Okay, so now we're all set, and we're ready to move to the OS X build instructions that you can find on the PIVX GitHub. Now the first thing it asks you to do, it says that you need to launch a terminal, which we've already done. That's what this green terminal is. First thing it's going to do after that is say you need to make sure that your macOS command line tools are installed. And the command for that is xcode select -- install. And you'll find that mine is already installed. So again, you're going to see, okay, command line tools are already installed. So that's fine. That's for me. You, on the other hand, if you don't have that installed yet, we'll go through a series of downloads and installations to install Xcode command tools. Now here's the biggie. So this line right here, and PIVX makes it easy. Again, you can just click this right here to add this to your paste buffer. This is going to use Homebrew to install all of the tools that are needed to configure and build PIVX. So it's very simple, one line. So I copied it to the paste buffer. I'm now going to paste it into the command line. You can see it here, brew install, auto config, auto make, Berkeley DB4. All of these are used by the PIVX config and build tools. I have already done this, so you're going to again see something different for me than what you will see. It's going to take quite some time for you to do this because it's going to go through all these packages, download them, get the latest, and get them installed. So that's the next step. Next, okay, now we're ready to go ahead and pull down the Git repository. And it's a very simple command for doing that, which is git clone. Now, what this does is it clones the PIVX repository. That's all the code in PIVX project on GitHub into your local directory. Now, I executed this command from my home directory, which means that it will create a PIVX folder directly underneath that home directory. And when this clone is done, it will cd to that PIVX directory. And I'll confirm that that's happened when this is over, so we can see which by executing a pwd command, which will say, hey, what directory are you in? Okay, so that's done. If I type pwd says working directory. Tell me what the working directory is. Working directory is PIVX, right under non11, which is my home directory. So that worked correctly. It cloned. If I do an ls, that tells me all the different files and subfolders that are in this PIVX directory. If every name that starts with a D is a directory, just like a folder, and the items that have an X are executable. You'll see all the directories are by default set to executable because you have to be able to get into them. Okay, so next command. Right here, very simple, build PIVX core. It's going to run a configuration file called autogen, and then it's going to run configure, and then after that, it's going to execute a make. A make command is actually the one that's going to call the make files and build the libraries. So let's click this, cross our fingers, hit Control V. Again, it's doing all three of these sequentially, and let's see what happens. So this is going to take some time to go through the configuration and then go through the build. You can see right now how it's going through checking for dependencies, checking configurations, seeing what's installed. This is why we had to go through that step through Homebrew of making sure that we had all of the appropriate tools and libraries and dependencies installed. And when this is done, we should be built. That's going to take some time, depending on how fast your computer is. It could take anywhere from 10 minutes to an hour or more. But you should see when it's all done building, it should say nothing to be done for all, and now you should be all set. So now let's go back to the instructions from the PIVX website and see what's next. So it recommends as a next step to install the unit tests and run the unit tests. So again, they have some handy command line arguments that you can just copy and paste. So we're going to do these two lines here, which is /param. So again, this is assuming that you're in the PIVX directory, the PIVX folder, and you're going to run this script, install params, and then you're going to call make check, which is going to build and run the unit tests. So let's try that. So you can see as we go, it will check each of these, how many passed, how many failed, and the total. Okay, so after going through building and executing all of the unit tests, hopefully they all came out saying they passed. Now we're well on our way. Now we've got PIVX downloaded, the source code downloaded, it's building, it's configured, it's passing all of the unit tests. There's a couple other things that we can do. We can actually make a DMG file, which is a traditional sort of Mac OS X file that we would install in applications. So I'm going to go back over to the instructions to show you how you would do that. So if you go to this section right here, if you want to do this, you're going to need some additional dependencies. So what we're going to need if we want to make that disk image file, DMG file, is we're going to need to install a library called rsvg. So I'm going to take this command here, just like we've done before. It's brew install lib rsvg in our terminal. And again, I have this installed, so you're not going to see much on my screen. And then the next thing that we need to do is this Python. We're going to do a pip3 install ds store and mac alias. And we'll get a couple of warnings about deprecated, something that's going to be deprecated in the future, but it nevertheless should be okay for now. So now you can just go down and run the make deploy command. So you see here make deploy. I'll copy this. And this is going to be somewhat noisy. And then you're going to see it's going to do some sort of fancy footwork to create the DMG file. And once that's done, it's going to say created users non11 PIVX pivxcore.dmg has been created. So if I bring this up, there it is, pivxcore.dmg, and I can double click on that, and here we go, welcome to PIVX Core. And then it's asking me, I'm not going to do this right now, this is asking me to set up the directory, and then it will download the blockchain, which will take quite a bit of time. So this is confirming that we have built it and we're able to execute it, the PIVX wallet. Now, if you take a look, just to confirm that, if I go ls minus altr on this file, it was created on August 3rd, and that's today. So that's one way to confirm that this is not an old DMG file that just has been in there and something else failed. No, it actually did create the new file, and we're up and running. Okay, now that we've built, downloaded the code, configured the code, built the code in release mode, ran through the unit tests, made sure everything was working, and then went through and did a make deploy, and we're able to launch the wallet app. I'm not going into details on configuring the daemon or getting it up and running as a node or a master node. Maybe that could be another video. But I did want to talk about a couple of other things. One, what we did so far was release mode. So it's worth noting that in debug mode, if you wanted to build in debug mode, when we went through the configure step, we did that configure and then we did the make. If you do configure -- enable debug and then do a make, this will then build the debug libraries. I'm not going to go through it now. It takes longer than the release build, so it takes some time, but then you'll have the debug libraries, which are needed for doing any sort of debugging. What I wanted to show now is how do you go about developing? What IDE do you use? You could use a simple text editor and edit files. If you look at where we are in PIVX, there's a source folder here, and there's lots of source files, right? So all these CPP files are files that have C++. You could use a very simple editor like VI and open these up and make a change and then go through the process of make, and it would rebuild it, and your edits would be reflected in the resulting libraries and executables. But that's not so nice. It's just not a great way to do it. It's nice to have a more integrated IDE. And there's several that are out there. I'm just going to show you one that's free that I've been playing around with, which is Visual Studio Code. So Visual Studio Code is kind of like the free version of Visual Studio, and they actually have a Mac version, which is kind of nice. So if you go to code.visualstudio.com, you can download Visual Studio Code. And this kind of just shows you how to do it. You go stable. They also have like a pre-release version. And it will download this. I've already have it installed on my computer, but I'm going to show this to you because it's a little bit different than downloading a standard Mac DMG file. It's going to be a zip file, and what you're going to need to do is, once it's downloaded, you can go and uncompress it, and then you have an application, and you can just go ahead and add that to your application. So it's a two-step process instead of one, but once you've done that, inside of your applications, you'll see Visual Studio Code. Okay, so that's kind of how you do that. I'm just going to go ahead and launch it. Okay, so there's two extensions that are needed really to take advantage of Visual Studio Code and its ability to parse CMake files to set up project environments. And I have both of those installed, but I'm going to show you what they are. The first one is C++ extension. So you can see here it says you can get this at Marketplace, visualstudio.com, and you can really just do a search for CPP tools and you'll find this. Or even better, when this is needed, Visual Studio Code will determine that this is available and ask you if you want to install it. So you click install, it'll say open Visual Studio Code to do this. You say yes, and it brings up this within Visual Studio Code. You can see that I already have it installed and it's asking me if I want to uninstall. So I don't want to uninstall it, so we'll just quit out of this, but that lets you see what that is. And then the second one that's needed is the CMake tools. So the CMake tools, same kind of thing. You see CMake tools here from Microsoft. Again, it's at the marketplace.visualstudio.com. Click install. It will ask you to launch Visual Studio Code, and then it will bring up this window. And again, you can see that it's already installed, asking me if I'd like to uninstall it. Once you have the extensions installed in Visual Studio, you can then go to File, Open Folder, and select the PIVX folder. Now remember, the PIVX folder has a CMake list.txt file. So since we now have the CMake extension installed, Visual Studio Code is going to recognize that this is a CMake configuration is available and auto-configure the environment based on what's in CMake list.txt. So if I go up here now, I'll see here, and it will ask me, would you like to configure project PIVX CMake tools extensions, and say yes. So now it's going through CMake. It's actually parsing the CMake list.txt and doing the configuration. And this is going to take a little bit of time. And now it's saying always configure projects upon opening. I'm going to say yes. And now it says users non11, PIVX, build. The build files have been written there. So this is kind of neat because you can go here now, and remember before we did a release using the command line. Well, now I can build and debug. I can select debug here, and then I can go build. And you can see here it says building all. It's going very quickly because I've already done this. It takes a long time, as I had mentioned before, to build everything in debug, but it's already done. And now what you can do, this is kind of nice, is you can actually select the target to launch here. So it's built all of the different executables. So there's the PIVX daemon, there's PIVX Qt, there's the PIVX command line tool, there's a benchmark test, the bench PIVX, and you can select any one of these. So what I'm going to do, just to give an example, is I'm going to select bench PIVX. And then what I'm going to do is go into the source files here, and you can see I've already opened it, and there is a subfolder called bench, and in here I'm going to look for a CPP file called let's do bench PIVX. Alright, so this is the file that's going to get called. It's built and compiled with the bench PIVX executable. And I'm going to put a breakpoint here. So I can put a breakpoint right at this location. And notice that you have also really nice colorization, and it uses what they call IntelliSense, which kind of will tell you the values of things as you go, which is really nice even while you're developing. It doesn't require it's not while you're in debug. While you're in debug, you can obviously inspect the values of variables in real time and do all sorts of other things. But with IntelliSense, it makes like learning the APIs very easy. So for instance, this run all, if I hover over it, it will tell me the return type. It's static void. It will tell me the all of the input parameters, how the API looks. So it's kind of very nice in that regard. So I've got a breakpoint right now at this declaration of scaling factor. And what I'm going to do is click on this bug button. And this is launching the debugger. So let me click on that. See, it's going to do a little rebuild here. And now you can see it stopped right here. And I can go to scaling string, and it'll tell me, the value of scaling string is 1.0. The scaling factor is actually undefined because it hasn't been defined here. It's just double, but it's actually going to take this value most likely. But then you can go here, and you've got all of your typical debug tools: step over, continue, step into, step out. I'll just show you this real quickly. Okay, stepped over that if. Moving on to this declaration, setting print arg. You can see what that value is afterwards. It's set to console. And then step over this, because if plot equals print arg was not true. And you get the idea, and then it's going to go into this run all, and I can even do a step in, and it goes into the run all. And so this is a really nice environment that gets you up and running with PIVX, and makes it very easy to debug, inspect, and develop within an integrated IDE environment. Thank you. I hope you found this video useful.